The Elasticity of Solids. Introduction. The elasticity of solids is a fundamental concept in physics and engineering, covering topics such as stress, strain, and Hooke's law. These concepts explain how solid objects behave when forces are applied, including how different materials respond to tension, compression, and bending. What is stress? Stress measures the internal force exerted on a material per unit area, occurring in three main ways: tension, which stretches an object; compression, which squeezes it; shear, which bends it. The formula for stress is given by stress equals force divided by area. Stress is measured in pascals, similar to pressure, although the force may not always be perpendicular to the surface, such as in shear stress. What is strain? Strain measures the amount an object deforms due to stress. It is a unitless ratio, indicating how much an object changes in length relative to its original length. For tensile or compressive forces, strain equals the change in length divided by the original length, where change in length represents the amount of length change, and original length is the length before the force was applied. For shear forces, shear strain equals the horizontal displacement divided by the original length, where horizontal displacement represents the amount shifted sideways. Practice problem. Calculating strain. A piece of rubber, originally 18 centimeters long, is stretched to 20 centimeters. What strain has it undergone? Solution. Change in length equals 20 centimeters minus 18 centimeters, which equals 2 centimeters. So, strain equals the change in length divided by the original length, which equals 2 divided by 18, or approximately 0.11. Hooke's law. Hooke's law describes the relationship between stress and strain in materials that remain elastic, meaning they return to their original shape once the force is removed. Stress equals modulus multiplied by strain, where Young's modulus applies to tension and compression, and shear modulus applies to bending. Practice problem. Applying Hooke's law. A steel rod with a Young's modulus of 2 times 10 to the power of 11 pascals is stretched by a force of 1,000 newtons. If the rod has an original length of 1 meter and a cross-sectional area of 5 square centimeters, by how much does it stretch? Solution. Change in length equals force multiplied by original length divided by Young's modulus multiplied by area, which equals 1,000 newtons multiplied by 1 meter divided by 2 times 10 to the power of 11 pascals multiplied by 5 times 10 to the power of -4 square meters. This results in a stretch of approximately 0.1 millimeters. Understanding Young's modulus. Young's modulus measures a material's stiffness. Materials with a high Young's modulus, like glass or steel, are harder to stretch or compress, while materials with a low Young's modulus, like rubber, are easier to stretch. Practice problem. Young's modulus comparison. Which material has a greater Young's modulus, rubber or glass? Solution. Glass has a higher Young's modulus, making it stiffer and harder to stretch compared to rubber. Shear modulus and bending. Shear modulus measures a material's resistance to bending or twisting. Hooke's law for shear stress uses the shear modulus instead of Young's modulus. Shear stress equals force divided by area, which also equals shear modulus multiplied by shear strain. Materials with a higher shear modulus are harder to bend. Practice problem. Shear modulus. Two metal beams are subjected to the same shear force. Beam X has twice the shear modulus of beam Y. Which beam will bend more? Solution. Beam Y will bend more, as beam X has a higher shear modulus, making it more resistant to bending. Applications of elasticity. In the real world, elasticity is crucial in structural engineering. Steel cables and bridges are designed to stretch slightly under heavy loads without breaking, while support beams in buildings compress slightly under weight, ensuring safe and efficient performance under various forces. Recap and key concepts. Stress measures the force applied to a material per unit area. Strain measures the deformation relative to the original length. Hooke's law states that stress is proportional to strain within the material's elastic limit. Young's modulus measures resistance to tension or compression, and shear modulus measures resistance to bending. If you found this video helpful, be sure to like, subscribe, and share it with your friends. For more interactive practice with elasticity, check out King of the Curve for a variety of learning tools. Thanks for watching, and see you in the next video.